In this video, we're going to go through a series of more challenging questions in the 2019 O-Level Chemistry Paper 1. For question 2, this is a question on experimental chemistry. The question talks about coming up with a method to determine the amount of sulfate ions present in seawater. The question goes on to tell you that seawater contains 4 ions: sodium, chloride, calcium, and sulfate. So again, the question requires you to determine the amount of sulfate ion present. For the quantitative determination of an ion that's dissolved in water, commonly we use a method called the gravimetric method, meaning we precipitate out the ion only, and then we weigh the mass of the precipitate obtained, and from mole calculations we can actually find the number of moles of sulfate present. So the key thing about this question is that since there are 4 ions present, we need to selectively precipitate out sulfate. So if we look at the options, there are actually 2 options that sound like the method that I've mentioned earlier. One is to add aqueous lead-2 nitrate. The other one is to add barium nitrate. So both methods appear to work because it can precipitate out your sulfate in the form of lead-2 sulfate, and in the case of barium nitrate, your barium sulfate. However, you need to take note that in seawater there is also chloride present. So in order for this method to work, we must be able to precipitate out sulfate exclusively. So in this case, A wouldn't be sound because A would also precipitate out your chloride, since we have learned that lead-2 chloride is also insoluble. For B, when we add barium nitrate, barium chloride is actually soluble in water, so it will only precipitate out your barium sulfate. Question 3 is on purification and separation, where we look at the different methods for separating mixtures. In this question, we are given 2 liquids X and Y. The question already states that both the mixture can be separated by either fractional distillation or separating funnel. So for the different methods of separation, we need to know the property in which the difference in that property allows X and Y to be separated. For fractional distillation, the method works by the different boiling points of the liquid, and for separating funnel, the method works by the different densities of the liquid. So the other information that's required in this question would be this, that for fractional distillation, the first liquid to be collected is the one of the lower boiling point, right? And the lower liquid in the separating funnel is the one of higher density. So with the information of X and Y given above, we can know that Y will be the first liquid to be collected, and the lower liquid has to be X. For question 5, this is an atomic structure question. Whenever you see a nuclide notation, it tells you that it's an atomic structure question. From the nuclide notation, we can actually determine the number of protons, neutrons, and electrons given the mass and the atomic number. So from again the mass and the atomic number, we can tell that the number of protons is 16. Since the question states an element Q, we can assume that it's an atom. There's no mention of an ion, so number of electrons would also be 16, and the number of neutrons therefore would also be 16. Next, the question tells you a particle R. Now whenever you see particle, you need to take note, because a particle can be an atom, it can also be an ion. So it tells you that it has 4 more neutrons, so 20, 1 more electron, 17, and 1 more proton, so 17. So based on the number of protons as well as the sum of number of neutrons and protons, we can tell that R would have the following nuclide notation, which is 37 and 17. The next thing to decide is whether R is an ion or an atom. Since the number of electrons and protons are the same, R would be a neutral atom, so the answer would be D. For question 6, we are looking at diamond and graphite, which in our syllabus we have learned that they are both carbon but with different arrangement of atoms. The same diamond and graphite representing carbon, same element, having different arrangements, we call them allotropes. For allotropes, one important thing to remember is that they have different physical properties, which is what we have learned. Diamond is strong and hard, but graphite is soft and slippery. Okay, the other thing to remember is that allotropes, they actually have the same chemical properties. That means they will undergo the same reactions, and when they undergo the same reactions, they form the same products. So over here, if you look at the 4 options, there's only one option talking about a chemical reaction or chemical properties, so that would be the correct answer. Question 7 is talking about structure and properties under chemical bonding. So over here, the 2 compounds in the question are ionic compounds, so they would have your giant ionic lattice structure with strong electrostatic forces of attraction between oppositely charged ions. So let's analyze the 3 statements and see which ones are correct. Number 1, potassium chloride has a higher melting point than calcium chloride because potassium ion has a greater charge than the calcium ion. Now this statement is obviously wrong because potassium ion has a charge of plus and calcium ion has a charge of 2 plus. So calcium ion actually has a greater charge than potassium ion. So this statement is already wrong. Now for those of you who are interested, how is melting point related to charge? Melting point of an ionic compound depends on the strength of your ionic bonds. Okay, and we have learned that ionic bond or ionic bonding is the attraction, electrostatic attraction between plus and minus, between your cation and your anion. So the thing is, the greater the charge, the stronger will be the electrostatic forces of attraction, then the higher will be the melting point. So an ionic compound made up of a metal ion with a greater charge would have stronger ionic bonds and therefore higher melting point. This is not really in the syllabus, but it is good to know. Next, statement 2, in the calcium chloride lattice, the ratio of calcium ions to chloride ions is half of that of potassium to chloride ions in potassium chloride lattice. So to know the ratio of anion to cation to anion, we just need to look at the formula of the compound. Calcium chloride is CaCl2, so each cation is paired with 2 anions, or each calcium ion is paired with 2 chloride ions. Whereas for potassium chloride, each cation is paired with 1 chloride. So indeed, the ratio is half of that of potassium chloride. So 2 is correct. 3, molten calcium chloride has greater electrical conductivity than molten potassium chloride because calcium contributes more electrons to the sea of delocalized electrons. Now this is obviously wrong. Why? Because when we are looking at ionic compounds, the charge carriers are your mobile ions, right? So it has nothing to do with electrons. Electrons are your charge carriers when we are looking at the metal elements, for example, calcium or potassium. So the correct answer is 2 only. Question 11 is a chemical calculation question, and there's something unique about this question, which is this, that the amount of both reactants are given in the question. What do I mean by that? The question tells you that you have 2.4 grams of magnesium. Based on that, we can find number of moles of magnesium. You are also given the volume and concentration of sulfuric acid. So when you're given volume and concentration of sulfuric acid, you can also find number of moles of sulfuric acid. When the amount of both reactants are given in a question, you need to make it a point to check whether any of them is limiting or excess. So how do we do that is to first find number of moles of magnesium. Given the mass of magnesium, we can take the mass divided by the molar mass. Molar mass of magnesium is 24, and that will give us 0.1 mole. Given the volume and concentration of H2SO4, we can find number of moles by taking concentration times volume. 100 centimeter cube is equivalent to 0.1 dm cube, and that would also give us 0.1 mole. So the number of moles of magnesium and sulfuric acid is the same. And if we look at the reacting ratio, which is 1:1, it means that the amount of magnesium and sulfuric acid is in stoichiometric ratio. That means just nice. We have just nice of magnesium reacting with sulfuric acid. At the end of the reaction, there will be nothing left but only products. So the question also tells you that 2.4 moles of hydrogen is actually formed, and the question requires you to then look at which option would give us 4.8 or 2 times the number of moles or 2 times the volume of product. Okay, let us analyze the 4 options now. In option A, the mass of magnesium remains unchanged, but the number of moles of acid times 2. So what will happen now is you need to ask yourself, will I get more product in that case? The answer is no. Why not? Because if the mass of magnesium remain unchanged and you increase the volume of only sulfuric acid, now sulfuric acid will become in excess and magnesium will be limiting. So the number of moles of hydrogen gas will still remain the same. Same thing for option B. The mass of magnesium remains unchanged, but the number of moles of sulfuric acid times 2. So again, what that would cause is that your sulfuric acid would then be in excess, and the number of moles of product will still remain the same. For option C, the mass of magnesium is doubled. So now we have more magnesium, but then your sulfuric acid concentration remains unchanged. So what happens in this scenario is that your magnesium will become in excess and your sulfuric acid will be limiting, and will still end up with the same number of moles of product. So it's only in D where we have an increase in the mass of magnesium and also an increase in the number of moles of acid. So now the reaction will produce 2 times the product, because now we have stoichiometric ratio and it's 2 times of the original amount. Question 12 is a mole concept question, and this is not easy, but after reviewing this kind of questions, I hope the method will come to you naturally. So since we are given the mass of your metal and the metal oxide, we can actually find the mass of oxygen in the metal oxide. And how do we do that is to take 4 minus 3.15. That would give us 0.85 grams. From mass, we can actually find number of moles of oxygen atoms by taking 0.85 divided by the molar mass of oxygen atoms. That would give us 0.053 moles. Okay. Now from there, we can actually find the number of moles of your metal. How do we do that is to look at the formula of your metal oxide. The formula of your metal oxide is XO2, meaning for every mole of X, there are 2 moles of oxygen atoms. I repeat again, since the formula is XO2, it means that for every mole of X, you have 2 moles of oxygen atoms. So given 0.053 moles of oxygen atom, we can therefore find the number of moles of X by dividing it by 2. That will give us 0.0265 moles. And now that we have the number of moles of X, we have the mass of metal X as well, 3.15. We can actually find the relative, we can find the molar mass by taking the mass divided by the number of moles. So what equation triangle we are using is this: number of moles, mass, and then molar mass. Okay, so the molar mass, if you calculate correctly, is 118.6. And if you can recall, the molar mass of an element is actually equivalent. It has the same value as your atomic mass. Okay, so the atomic mass of X would be 118.6 or close to 119. That would also mean that the X is likely to have a mass number of 119. So the option is C. Question 14 is an electrolysis question. We are looking at the electrolysis of aqueous copper 2 sulfate. Now this is a standard example in our syllabus where we look at what happens when we use inert electrodes and what happens when we use active electrodes like copper itself. But the unique thing about this question is that the positive electrode is made of carbon and then the negative electrode is made of copper. So how is that going to affect the electrolysis, or how is it going to affect the products of this electrolysis? Now, when we were learning the electrolysis of a solution using active electrode, remember, an active electrode will only take part in the reaction at the anode or the negative electrode. So what electrode you use at the positive electrode or the cathode makes no difference. In this case, since the copper, the active electrode, is at the negative electrode or at the anode, what is going to happen is that your copper is going to take part in the reaction to form your copper 2 ions. So what happens is that your electrode will dissolve, and that will give you the answer already. At the cathode, what will happen is that your copper ions in solution is going to be reduced to copper metal. So that's why you have copper deposited at the negative electrode. One thing to note for electrolysis questions is that Cambridge likes to use the terms positive and negative electrodes instead of cathode and anode. So you are required to make the mental switch to know that positive electrode is your cathode and your negative electrode is your anode. Question 16 is on a chemical energetics question. In this question, you are given 3 fuels and the enthalpy of combustion for each fuel. Now, one thing to note about enthalpy of combustion would be the units, kilojoules per mole. Now, what it means is that for every mole of the fuel undergoing combustion, it will produce this amount of heat. For example, hydrogen, for every mole of hydrogen undergoing combustion, 286 kilojoules of heat energy will be released. So based on that knowledge, let's look at the 3 statements. From the statements, you can see instead of per mole, the question seems to be talking about grams. 1 gram per gram of fuel. So this question requires you to convert the enthalpy change of combustion from kilojoules per mole to kilojoules per gram, we want to know per gram of fuel how much heat is released. So from a mole, how do we convert it to per gram? Is that you then need to find out for each gram of fuel how many moles of fuel is present. So 1 mole of each fuel is equivalent, 1 gram of each fuel is equivalent to how many moles. So to do that, we need to know the molar mass of each fuel, and then we take 1 gram divided by the molar mass. And then from there, after finding number of moles per gram, we multiply it by enthalpy of combustion to get the enthalpy of combustion in kilojoules per gram. So I've done the calculations over here. You can see that I have converted the enthalpy changes from kilojoules per mole to kilojoules per gram. So this means that, for example, for hydrogen, for each gram of hydrogen undergoing combustion, I will get 143 kilojoules of heat released. So let us now take a look at the statements again. Octane produces more heat than hydrogen or methane for each gram of fuel. Now this is wrong. We can see from the numbers over here that octane will produce less heat than methane and hydrogen for each gram of fuel. Next, on complete combustion, 1 gram of hydrogen produces 286 kilojoules of energy. This is also wrong because for each mole of hydrogen, it is made out of 2 grams of hydrogen. Okay, so actually once you have ruled out 1 and 2, obviously the answer is 3 only. But why is it 3 only? For enthalpy change of combustions, they are always exothermic. Delta H is always negative. When you have an exothermic reaction, it can only mean one thing, that the total energy given out during bond forming or in bond forming is greater than the total energy required for bond breaking. Question 17 is on rate of reaction. We are looking at the rate of reaction for the reaction between magnesium and hydrochloric acid. The question gives you the mass of magnesium and the concentration and volume of hydrochloric acid. For questions like this, it's routine for us to find which one is limiting and which one is in excess. Okay, reason being, if we change the number of moles of limiting reactant, then the number of moles of gas produced would change. Okay, so I would do a quick calculation, and the number of moles of magnesium is mass over molar mass, so it is 0.05 moles. And the mass of acid, if you look at the number of moles, the number of moles of acid, if you look at the volumes and the concentration, you will find that the number of moles of hydrochloric acid in experiment 1 is actually equal to that of experiment 2, meaning the number of moles of both reactants in experiment 1 and 2 are the same. So in this case, there's no point in checking limiting or excess because there's no change in the number of moles of any reactant. Okay, that would also mean that there will be the same volume of gas produced in both experiments. Next, we need to check which one, whether B or D is correct. So for rate of reaction, we need to remember that it depends on the concentration of your acid or the concentration of your reactants. So if we look at experiment 2, it has a higher concentration than experiment 1. So that means that the rate of reaction of experiment 2 will be faster, and the rate of reaction is manifested, shows up on the graph as the initial gradient. So meaning the initial gradient of experiment 2 must be greater than that of experiment 1. So D is the correct answer. For question 21, you need to combine knowledge from a few chapters in order to solve the question. So first and foremost, the question tells you that it is a white solid. So since the solid is not colored, we can immediately rule out B because copper 2 carbonate is colored, or we can rule out those that contains a transition metal ion. Next, Y dissolves in water, so we can then now apply our solubility rules to rule out those solids or those mixtures that contains solids that are insoluble, like calcium carbonate. And then we are left with the two options C and D. Last, the next line, when you react with an acid, bubbles are produced. So you need to recall acids. What are the three things that acids can react with, and in which reaction would a gas be produced? So very obviously we are looking at the reaction of an acid with a carbonate. So let's take a look at the mixture and we look for one that has a carbonate. D doesn't have a carbonate, so the answer must be C. Now for education purposes, let's look at the last statement. When chlorine is bubbled through an aqueous solution of Y, the solution turns red-brown. So what is happening here is chlorine. When you see chlorine, you need to think of periodic table, you need to think of halogen displacement. So what is happening here is that chlorine, being a more reactive halogen, will displace your bromide from the salt solution. So bromide will come out as bromine, and aqueous bromine is actually reddish brown. Question 26 is predominantly on periodic table. And when you see that they talk about vanadium having various oxidation states and forming colored compounds, you should be immediately reminded of transition elements. And next you need to recall what are the other properties associated with transition elements. So if you can recall, transition elements have high melting points, high boiling points, high densities. Transition elements are good catalysts, or their compounds are good catalysts. So immediately we can rule out C and D, and B seems to be correct. So what is left to be done is that we need to check whether A is equally correct or not. So the question states that it changes from violet to blue-green. Violet will be V2 plus and blue-green is V3 plus. So this increase in charge or the increase in oxidation state would represent oxidation rather than reduction. So A is wrong. Question 29 is on the reactivity series, and this is a tricky question. In the reactivity series, we learn that metals below carbon can be obtained from its oxide by heating with carbon. So now we have narrowed down the metals to those below carbon, meaning it has to be copper, lead or silver. Next thing is that it can be obtained from its aqueous chloride by electrolysis. For a metal to be extracted from an aqueous solution, remember aqueous solutions would contain H+, right? It means that the metal ion must be below H+ in the electrochemical series, and that would mean that it would be either copper or silver. Now unfortunately we have both copper and silver as the options, so which one is correct? Now again, aqueous chloride means that it's dissolved in water. So you need to ask yourself, copper chloride, copper 2 chloride and silver chloride, which one can dissolve in water? And if you can think of that, we would have isolated the answer to be copper 2 chloride, because silver chloride is a solid. It cannot be an aqueous chloride. Question 36 is an organic chemistry question. So we are given two isomers of butene and a series of statements. So let us take a look whether the statements are correct. The first statement, both decolorize bromine water. This is correct. As long as the molecule contains a carbon-carbon double bond, regardless of the position of the carbon-carbon double bond, it's going to react with bromine and decolorize bromine. The second statement states that both will produce the same molecule when reacted with bromine. That is not correct. The important thing to remember about addition is that the added atoms are added across the carbons in the double bond, the carbon atoms having the double bond. So your bromine will be added across this 2 carbons for the first isomer and this for the second isomer. So from the product that we see, we can tell that they are different because the bromines are on carbons 1 and 2 for the first isomer and carbons 2 and 3 for the second isomer. So they are going to be different. However, when you add hydrogen, remember all your other carbon atoms are also bonded to hydrogen. So no matter where the carbon-carbon double bond is, if you add hydrogen to it, it will form the alkane. So both will end up with butane and they are the same molecule. When polymerized, the same polymer is produced. For an alkene undergoing addition polymerization, to get the polymer or to get the repeat unit, we must first rearrange the alkene into the H configuration like that. Okay, so for the first isomer, or for the isomer on the left, we are going to have, it's going to look something like this. And for the isomer on the right, it will look something like this. Okay, so from the monomers, once you arrange it in the H configuration, you'll be able to tell that the repeat unit would look different. So you end up with a different polymer when the isomers are polymerized. So there are 2 statements, 2 correct statements, statement 1 and statement 3. Question 39 is on the homologous series of esters. So for an ester, we need to, when given the structure of an ester, we must be able to deduce the carboxylic acid and the alcohol that had reacted to form the ester. Now the slightly challenging thing about this question is that the ester is given in condensed formula. So from the condensed formula, you must be able to recognize that this CO2 actually represents COO. So this is the ester, C3H7, COOCH3. Now once you can draw out the ester functional group, I think it becomes very easy. To get back your acid and alcohol, we need to first locate the CO single bond in the ester functional group. Next, we need to erase this CO single bond. Now you should be able to see your acid fragment and your alcohol fragment. Alright, so you need to add OH back to your acid fragment and you need to add H back to your alcohol fragment. So from there, we'll be able to tell the correct answer to be D. Question 40 is a polymer question, and in the question we are given the structure of a section of a polymer. From the structure, we should be able to tell that the polymer is actually an addition polymer. Why? Because there is no amide linkages, there are no ester linkages, so it must be an addition polymer. So B is wrong. Next, for this question, it's easier to solve by elimination rather than to find the correct answer. What do I mean by that? Is that if you look at C, its monomer has the empirical formula C4H6Cl2. Now, if we can recall empirical formula to be the molecular formula in its simplest ratio, you would realize that this doesn't make sense because the formula given can be further reduced, can be further simplified. So this cannot be the empirical formula. Next, For D, option D is obviously wrong as well. Why? Because the reaction of an alkane with a chlorine will give chloroalkane, and chloroalkanes are also are saturated, so they don't contain a carbon-carbon double bond. When you add chlorine to an alkane, it doesn't make it an alkene, and to form an addition polymer, we need an alkene. So D is obviously wrong as well. So the correct answer must be A. But this question is a bit misleading. I'll tell you why now. So given the structure of an addition polymer, how do we deduce the monomer? Is that we need to find the repeating unit first. So I've already isolated the repeating unit, and after finding the repeating unit, to get back the monomer, we need to erase the dangling bonds and to add back the double bond. So when you look at the structure of the monomer that I've created above, it seems to differ from what is given in option A. Now that's especially obvious if you have learned something called cis-trans isomerism, which is not in the syllabus, meaning you see this group is opposite to each other in the alkene, and these two groups are on the same side of the carbon-carbon double bond, right? So why is A still correct? Now it's because of this. When we look at the polymer, the polymer is an alkane, right? It doesn't have any carbon-carbon double bond, so the groups can be freely rotated, meaning it does whether we put H on the same side or we put H on different sides, it actually carries no meaning in an alkane because it can be freely rotated. So meaning the polymer can also be written like this, where we put H on the same side and your CH2Cl on the other side. So these two polymers are equivalent. Okay, so once you have rotated the two hydrogens to be on the same side and you take the same steps to find the monomer, you will now find that the monomer looks more similar to the one given in option A.